Hello students, good morning. I hope you all are safe and healthy at your home. Welcome in this lecture. In today's lecture, we discuss about our heterocyclic compound benzofuran. Benzofuran. We discuss furan, 5 member, one heteroatom oxygen is known as furan, and benzo condensing compound benzo condensed furan is not at benzofuran. It is denoted by its structure. We write down, then one oxygen heteroatom is condensed with benzene, so it is known as benzofuran, and it is also known as coumaron. Coumarone. Coumaron, not zone. Coumaron. So we start. Today's our topic is benzofuran. It is occur from coal tar. Natural benzofuran is occur from coal tar. And synthetically we have a different routes for the benzofuran. We have a two different routes. So let us see one by one. First synthesis is from coumarin. Coumarin. Benzofuran is prepared from coumarin. Coumarin is optical brightening agent. Double benzene ring with oxygen. This is structure of coumarin. 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 This is coumarin. Bromination reaction takes place. Addition reaction. Takes place. So we get bromo derivative of coumarin. Bromo derivative of coumarin. And this structure we describe similarly as this benzene ring is we noted by as here bromine and here bromine. So it is treated with potassium hydroxide. 2 moles of potassium hydroxide takes place. So benzene ring is decomposed and we get derivative of benzofuran. And takes decarboxylation. So it is converted into benzofuran, or it is known as cumaron. So this synthesis is conversion of coumarin to cumaron, coumarin to cumaron. So we get coumarin to benzofuran, and here loss of 2 potassium bromide. This is first preparation from coumarin. Now we have second one also, second route for benzofuran. It is from salicylic acid. It is from salicylic acid. Second route from salicylic acid. Sodium salt of salicylic acid. And this is treated with ethyl bromoacetate. Ethyl bromoacetate. This is ethyl bromoacetate. Then we get derivative of salicylic acid. CH2COOC2H5. Derivative of salicylic acid and ethyl acetate. Salicylic acid and ethyl acetate. Now cyclization takes place with the help of sodium ethoxide C2H5ONA. Cyclization takes place. So we get benzofuran, derivative of ester. Now we takes place two reaction on this derivative. First is hydrolysis. First takes place hydrolysis, and second decarboxylation. So it is converted into oxide derivative, and now this compound undergoes two reactions. One is reduction and second is dehydrogenation. So we get benzofuran. We have two synthetic route. One is from coumarin and second is from salicylic acid. Now we see properties of benzofuran. Physical properties: it is colorless liquid, having boiling point 175 degrees Celsius. 175 degrees Celsius. Weak base and having aromatic properties. It is more stable than furan. It is more stable than furan and it undergoes substitution in position 2. In position 2, we give numbering 1, 2, 3, 4, 5, 6, 7, 8 and 9. Then substituted group is introduced in the second position at this position. So physical property: it is colorless liquid having boiling point 175 degrees Celsius, weak base and having aromatic properties, and it is more stable than furan. It undergoes substitution reaction at position number 2. Position number 2. Now we see some examples for the chemical property benzofuran. With the help of nitrating mixture in acetic acid, nitrating mixture with acetic acid, we get 2 nitro 2-nitrobenzofuran. 2-nitrobenzofuran. When we takes place sulfonation process, then two substituted sulfonic acid derivative benzofuran 2-sulfonic acid is obtained. Chlorination takes place. Halogenation. Chlorine, bromine, iodine, etc. halo group is introduced at second position. So 2 chloro, 2 bromo, 2 iodo benzofuran is obtained with the help of POCl3 phosphorus oxytrichloride. Formylation takes place, so we get 2-formyl benzofuran. 2-formyl benzofuran. 2-formyl benzofuran. If we takes place acetylation, then acetyl group introduced in second position with the help of acetic anhydride Ac2O and BF3 acetylation. takes place. So 2-acetyl COCH3 2-acetyl benzofuran is obtained. Benzofuran is obtained. And when one more important reaction for furan, benzofuran, when we treated reduction takes place, then we get cumaran. This is 2,3 dihydrobenzofuran, and it is known as cumaran. This is cumaran. When reduction takes place, benzofuran, cumaron is converted into cumaran. And if diphenyl derivative is treated with, then we get one more useful derivative. It is known as dibenzofuran. This is dibenzofuran. And numbering is very important for this. 1, 2, 3, 4, and this heteroatom oxygen contains 5 number 5, 6, 7, 8, 9. These are the numbering of one important derivative, dibenzofuran. Here we complete our second fuse compound, 5-member heterocyclic, one or more heteroatom fuse compound, benzofuran. Now we have one compound for 5-member ring, and that is benzothiophene. We studied well about thiol. Sorry for disturbing. We have 5-member heterocyclic compound. Heteroatom is sulfur, then it is thiophene. And now this is benzothiophene. So thiophene is condensed with benzene. That is benzothiophene. And structure is written by this. Benzothiophene. Thiophene, only 5-member. This is thiophene. And it is condensed with benzene, then it is known as benzothiophene. We have two synthetic routes for preparation of benzothiophene. Now we see First route, synthesis of benzothiophene. Benzothiophene is synthesized from ethyl benzene, our first preparation. Ethyl benzene. Benzene ring contains ethyl, CH2CH3. This is ethyl benzene. Treated with H2S, hydrogen sulfide gas, in the presence of Al2O3, Al2O3 and loss of 3H2, we get benzothiophene. We get benzothiophene. This is our first synthetic route, hydrogen sulfide. H2S. So, interaction between ethyl benzene and hydrogen sulfide in presence of Al2O3 gives benzothiophene. Benzothiophene. We have also second route for the benzothiophene. So, second, preparation of benzothiophene. Benzothiophene is prepared from thiophenol. We have a structure. Benzene ring contains SH at first position. It is known as thiophenol. Thiophenol. So, thiophenol is treated with acetylene. CH triple bond CH. This is acetylene. Acetylene. These both are thiophenol and acetylene at 600 to 650 degrees Celsius. Removal of H2 gives thiophene. Benzothiophene. So, this is second important synthetic route for preparation of benzothiophene. We have two synthetic route. First from ethyl benzene and hydrogen sulfide, and second from thiophenol and acetylene. Now we see properties of benzothiophene. Benzothiophene is colorless solid. Properties: colorless solid, having melting point, low melting point compound. It has only 32 degrees Celsius temperature. So, in summer days, benzothiophene is in form of liquid. It is much more stable and less reactive than thiophenol. It is much more stable. Much more stable and less reactive than thiophenol. It gives three substituted reaction. So, reaction with different compounds, that is number 1, 2, 3, 4, 5, 6, 7. So, 3 substituted. The group of different reaction enters at position 3. So, it gives three substituted reactions. Let us we see different types of reaction, chemical reaction of benzothiophene. This is benzothiophene. First of all, we see nitration with the help of nitrating mixture. HNO3 and H2SO4 gives nitrating mixture. So we get three substituted benzothiophene. Sorry. Three nitro benzothiophene. Halogenation. Halo group. Chlorine, bromine, iodine enters at position 3. That is 3-chloro-benzothiophene, 3-bromo-benzothiophene or 3-iodo-benzothiophene. Carboxylation takes place. Here we have a one very important reaction. Carboxylation. Then carboxylic acid introduced at position 3. And it is known as benzothiophene 3-carboxylic acid. Benzothiophene 3-carboxylic acid. Acetylation takes place. Acetylation takes place with the help of acetic anhydride. Then 3-acetyl benzothiophene. 3-acetyl benzothiophene COCH3. This is 3-acetyl benzothiophene is obtained. Benzothiophene is obtained. If alkylation takes place, alkylation. Alkylation takes place with the help of C4H9Li, lithium. So this is metal. Lithium is introduced, substituted at position 2. At position 2, and his compound is 2-lithium. 2-lithium benzothiophene. Benzothiophene. So alkylation with the help of C4H9Li, lithium butyl, we get 2-lithium benzothiophene. 2-lithium benzothiophene. And one more important derivative. In benzofuran we see dibenzofuran, and in this topic benzothiophene we have its very important derivative dibenzothiophenone. Dibenzothiophenone, and it is derived from diphenyl. We have structure. This is diphenyl. It is treated with sulfur powder in presence of AlCl3 aluminium trichloride at 250 degrees Celsius. So we get dibenzothiophenone. And numbering is start from here. So heterocyclic atom sulfur get number 5, and its very important property, its melting point is 100 degrees Celsius. So with the help of sulfur and aluminium trichloride at 250 degrees Celsius, diphenyl is converted into dibenzothiophenone. So it is very important chemical properties of benzothiophenone. Today we complete heterocyclic compound as 5-member ring heterocyclic compound, simple compound and fused compound, and we will see in next lecture with 6-member ring heterocyclic compound, 6-member, 1 heteroatom, 2 or more heteroatom, and in 2 or more and simple compound and fused compound. So we will see this compound in next lecture. Remaining heterocyclics like pyridine, pyran, pyridiazine, pyrimidine, pyrazine, quinoline and benzoxazine are remaining heterocyclic compounds. So in next lecture we will see this remaining compound one by one. Okay, thank you.